Welcome to the channel. Today we explore one of history's most dramatic engineering failures. In 1967, the ambitious frontier of human spaceflight was met with a stark and unforgiving reality. The Soyuz 1 mission culminated in a fatal re-entry crash, an event that reverberated as a major engineering disaster across the global space community. What were the inherent risks of venturing beyond Earth's atmosphere? And how did such a catastrophic outcome reshape the future of space exploration? In the year 1967, the world of space exploration bore witness to a profound and tragic event: the Soyuz 1 fatal re-entry crash. This incident was officially recognized as a major engineering disaster, marking a somber moment in the early chronicle of humanity's attempts to journey beyond Earth. The core fact established is that a spacecraft designated Soyuz 1 experienced a catastrophic failure during its return to Earth, resulting in a fatal outcome. The provided source text, however, does not elaborate on the specific sequence of events that unfolded during this fatal re-entry crash. While it confirms the occurrence in its classification as a major engineering disaster in 1967, critical details such as the precise timeline of the failure, the conditions leading up to re-entry, or the immediate moments of the crash itself are not described. Therefore, the exact narrative of what happened remains largely unarticulated within the given information. The event in question centers around a spacecraft known as Soyuz 1. While the designation of this mission is clearly provided, the source material offers no further details regarding its specific objectives, the crew assigned to it, or the broader scientific or exploratory goals it was intended to achieve. We know only that Soyuz 1 was the name of the mission that tragically concluded with a fatal re-entry crash in 1967, an event classified as a major engineering disaster. The ambition and scope typically associated with early spaceflight missions, including the hopes and expectations placed upon them, are not detailed in the provided text concerning Soyuz 1. The document solely identifies the mission by name and the year of its catastrophic conclusion. Without additional context, the full significance of this particular flight, beyond its ultimate classification as a disaster, cannot be fully conveyed. The path to any major engineering disaster often involves a series of warning signs, anomalies, or concerns raised during development, testing, or even during the mission itself. Such indicators can offer crucial insights into the evolving risks and potential points of failure within a complex system like a spacecraft. However, the provided source text for the Soyuz 1 fatal re-entry crash in 1967 does not furnish any information regarding such warning signs. There is no mention of any pre-existing issues, operational alerts, or specific concerns that may have arisen before or during the Soyuz 1 mission that could have foreshadowed the eventual catastrophic outcome. The document solely focuses on the classification of the event as a major engineering disaster, without detailing any preceding indicators or moments of doubt that might have been observed by engineers, mission controllers, or the crew. The Soyuz 1 fatal re-entry crash in 1967 is explicitly identified as a major engineering disaster, and the source text indicates that it involved a failure mechanism. This acknowledgement confirms that a specific identifiable technical malfunction or design flaw was at the root of the catastrophe. Understanding such mechanisms is paramount in preventing future incidents and advancing spaceflight safety. However, while the existence of a failure mechanism is stated, the provided source material does not offer any description or details about what this mechanism entailed. The specific engineering component, system, or process that failed, and how that failure precipitated the fatal re-entry crash are not explained. Without this critical information, the precise technical chain of events that led to the disaster cannot be reconstructed or analyzed based on the given document. How do such catastrophic engineering failures, when their mechanisms are fully understood, fundamentally alter the design philosophies of subsequent spacecraft? The immediate aftermath of the Soyuz 1 mission was defined by its tragic conclusion, a fatal re-entry crash in 1967. This outcome inherently signifies the loss of life and the devastating impact on the space program. The classification of the event as a major engineering disaster further underscores the severity and the profound consequences that followed this catastrophic failure. Beyond stating that the crash was fatal, the provided source text does not offer specific details about the broader aftermath. It does not describe the immediate reactions of the space community, the specific human cost, or any operational responses that occurred in the wake of the disaster. The document confines its reporting to the core facts of the crash being fatal and a major engineering disaster, leaving the subsequent events and impacts largely unaddressed. Following the Soyuz 1 fatal reentry crash in 1967, an investigation would undoubtedly have been initiated to ascertain the causes of what was unequivocally deemed a major engineering disaster. Such inquiries are critical processes designed to uncover the root causes of failure, identify specific shortcomings, and ultimately inform future design and operational practices. The source text confirms that lessons were learned from this event, implying a thorough examination of what went wrong. However, the provided source material does not detail any specific findings or conclusions drawn from the investigation into the Soyuz 1 disaster. While the event's classification as a major engineering disaster is clear, the document does not elaborate on how this conclusion was reached, what specific engineering flaws were identified, or the precise mechanisms of failure that were uncovered. In the face of such a profound engineering disaster, how are the lessons truly internalized and translated into tangible, preventative measures for future endeavors? The Soyuz 1 fatal reentry crash in 1967, classified as a major engineering disaster, is acknowledged to have resulted in lessons learned. This indicates that the tragedy was not merely an isolated event, but one that contributed to the evolving body of knowledge and safety protocols within human spaceflight. Such lessons, though born from catastrophe, are vital for the continuous improvement and safeguarding of future missions. Despite the acknowledgement of lessons learned, the provided source text does not specify what these lessons were, how they were implemented, or their direct impact on the design, testing, or operational procedures of subsequent Soyuz missions or the broader space program. The document provides no details on the specific changes or improvements that emerged from this major engineering disaster. Thus, while its contribution to learning is affirmed, the tangible aspects of its legacy remain undescribed within this particular source. The Soyuz 1 fatal reentry crash of 1967 stands as a stark reminder of the inherent dangers and formidable challenges associated with pioneering human spaceflight. Classified definitively as a major engineering disaster, this event undeniably left an indelible mark on the early history of space exploration. While the specific details surrounding the mission's objectives, the precise failure mechanism, or the comprehensive aftermath are not elaborated in the provided source, the overarching fact of a catastrophic engineering failure leading to a fatal outcome is clear. The acknowledgement of lessons learned from this tragedy underscores its significance as a pivotal, albeit somber, moment in the development of space technology and safety protocols, even if those specific lessons are not detailed. The journey into space has always been one of immense risk and profound consequence, demanding relentless innovation and an unwavering commitment to safety. Disasters like Soyuz 1, despite the limited information available in this record, reinforce the critical importance of understanding and mitigating every conceivable risk. They serve as a testament to the high stakes involved in humanity's quest to explore the cosmos, compelling engineers and mission planners to constantly refine their approaches. What are your thoughts on how early spaceflight disasters, even when details are scarce, continue to shape our understanding of risk and resilience in exploration? Share your insights in the comments below. Thanks for watching. If you enjoyed this, please like and subscribe for more engineering history.